Wave optics, interference of light. Interference of light is the phenomena of multiple light waves interfering with one another under certain circumstances, causing the combined amplitudes of the waves to either increase or decrease or completely get cancelled. Constructive interference. It occurs when the phase difference between the waves is an even multiple of pi or 180 degree. This is wave number one, this is wave number two. They are in same phase. So combined result means amplitude of the resulting wave will be larger. Destructive interference. If the crests of one wave coincide with the troughs of other wave, the resulting amplitude is decreased or may even be completely cancelled. Here, this is first wave, this is second wave, this is crest. It corresponds to trough of second wave. This is trough of first, and this is crest of second. So similarly, they combine in such a way that crest of one combines with trough of another, and hence the resulting amplitude may be very less or completely zero. Now, expression for intensity at any point using Young double slit experiment. These are two slits. They are created from single source, and this is a screen. At this point, suppose one wave is y1, another wave is y2. They are reaching at this point and they are interfering. So we have to find out the expression for intensity. So let's write first wave as y1 equals a1 sine omega t, and the second wave as a2 sine omega t plus phi, where phi is phase angle between the two waves. A1, A2 are amplitudes of the waves respectively. So on interfering, so they combine. So A1 sine omega t plus A2 sine omega t plus phi, and then we open this bracket. So A1 sine omega t plus A2, this will become sine omega t cos phi, sine omega t cos phi plus A2 cos omega t sine phi. From here, we can take out sine omega t. So A1 plus A2 cos phi times sine omega t plus A2 sine phi cos omega t. Now we make certain assumptions. So we write A1 plus A2 cos phi equal to capital A1 plus A2 cos phi equal to capital A cos theta, and A2 sine phi equal to capital A sine theta. So equation this y equal to A cos theta sine omega t plus A sine theta cos omega t, which will become y equals A sine omega t plus theta, which will represent a simple harmonic wave. Now we have to determine the value of capital A, amplitude of resulting wave. So for that, we add these two equations by squaring them. So it will become A square cos square theta plus sine square theta equal to A1 plus A2 cos phi whole square plus A2 square sine square phi. This will give A square equals A1 square plus A2 square plus twice of A1 A2 cos phi plus A2 square sine square phi. Here I have missed cos square phi. Now these two terms will combine, and they will give a square equal to a1 square plus a2 square, then within bracket cos square 5 plus sin square 5 will become 1. So we write a2 square plus twice of a1 a2 cos 5. Now we multiply each term by k, proportionality constant. So k a square equal to k a1 square plus k a2 square plus twice of a1 a2 k times cos phi. Here we know that intensity is directly proportional to amplitude square. So intensity equal to k times a square. This is why I have multiplied each term by k. So now write as I equal to, this is I1, this is I2 plus twice of root I1, I2 times cos phi. Here, this term is called interference term. On the basis of this term, it will be decided that there is constructive or destructive interference. Now we are going to consider the condition for constructive and destructive interference. So the decisive factor is cos phi. When cos phi is plus 1, it will be constructive, and when cos phi is minus 1, it will be destructive. So let's write it. So constructive interference. We know that for path difference lambda, phase difference is 2 pi. So we can write the condition for phase difference. So we say lambda corresponds to 2 pi. So unit will correspond to 2 pi by lambda. So P path difference will corresponds to 2 pi P by lambda. So for constructive interference, cos phi must be equal to 1, which will give phi equals 0, 2 pi, 4 pi, etc. And corresponding phases are these. So we can say 2 pi p by lambda must be equal to 0, 2 pi, 4 pi, etc. From where we get p equals 0, lambda, 2 lambda, 3 lambda, etc. So we can say that for constructive interference, the value of p must be either 0 or lambda or 2 lambda or 3 lambda, etc. Now let's see the condition for destructive interference. So for destructive interference, cos phi must be equal to minus 1, and in that case phi will be equal to either pi or 3 pi or 5 pi, and corresponding phase is this. So we can say that 2 pi p upon lambda must be equal to either pi or 3 pi or 5 pi, etc., which will give p equal to lambda by 2 or 3 lambda by 2 or 5 lambda by 2, etc. So this is condition for destructive interference. Thank you for watching.